Opinion: Intel focuses on 5G infrastructure Atom and Xeon parts for networking, among other Intel innovations. The big picture: as with many other computing platforms, it's the software that's driving the biggest innovations in networking. By building on more standardized hardware platforms, x86 for Intel and ARM for Marvell, and leveraging open-source software tools and platforms, like Linux, companies can create networking-related innovations at a faster and more efficient pace. Despite the cancellation of this year's Mobile World Congress show in Barcelona, quite a few tech companies are still making important announcements that were originally planned for the show. Not surprisingly, several of those announcements are focused on 5G. One of them, perhaps somewhat surprisingly, comes from chip leader Intel. The company sold its 5G modem business assets to Apple last fall, and many considered that move to be the company's exit from the 5G world. But Intel has a much bigger, though significantly less well-known, business creating chips that help power the network infrastructure equipment that sits at the heart of today's 4G LTE and 5G networks, including base stations and other core components. For years, much of the network silicon inside these devices was custom designed and built by the vendors making the equipment, companies like Ericsson, Nokia, Huawei, etc. However, with the growth of more software-based networking advancements, including things like network function virtualization, NFV, as well as increasing demand for general compute performance to handle applications like AI at the edge, Intel and other specialized vendors like Marvell have seen strong interest in their off-the-shelf merchant chips. To better address those needs, Intel made several different announcements focused on adding the computing power and specialized resources that new 5G networks require at multiple points along the network path. Starting at the network edge, the company introduced a new version of its Atom processor, the P5900, that's specifically targeted towards wireless base stations. Based on a 10 nanometers process technology, the new SoC, system on chip, integrates a next-generation set of Atom CPU cores along with network acceleration functions that are specifically targeted for radio access functions, small cells, and other edge-of-the-network applications. Given the strong expected market for 5G-focused small cells that millimeter wave, mid-band sub-6 GHz and CBRS-based spectrum demand, as well as the potential to do cloud-based computing workloads on the edge, such as AI, this looks to be a very interesting opportunity. For more compute-intensive workloads at the core of the network, the company also chose to make a number of additions to its second-generation general-purpose Xeon scalable server. For more on this story, visit the news article link.